Imagine the universe is a giant puzzle, and scientists have a guidebook called the Standard Model that explains how all the tiny pieces, like particles and forces, fit together. It's worked great for decades, predicting how stuff like electrons and protons behave. But now, there's this thing called the Muon anomaly, and it's like finding a puzzle piece that doesn't quite fit. That's exciting because it could mean we're about to discover a whole new section of the puzzle. So, what's a muon? It's a particle, like an electron's heavier cousin. It's super tiny, found in atoms, and spins like a top in a magnetic field. Scientists measure how much it wobbles, called its magnetic moment, using huge machines at places like Fermilab. The Standard Model predicts exactly how much that wobble should be, down to crazy precise numbers. But in experiments, the muon's wobbling just a tiny bit more than expected. It's like if your phone's GPS said you're moving at 60 miles per hour, but you're actually going 60.0001. Tiny difference, right? But in physics, that's huge. This mismatch is the Muon anomaly. Why is it such a big deal? Because the Standard Model is like the ultimate cheat code for the universe. It's never been wrong before. If the muon's doing something unexpected, it could mean there's stuff out there we don't know about. Maybe new particles, new forces, or even new rules for how the universe works. It's like if you're playing a video game and find a secret level no one knew existed. What could this mean? First, it might point to something called supersymmetry. That's a theory saying every particle has a hidden partner. These partners could explain weird stuff like dark matter, that invisible stuff making up about a quarter of the universe. If supersymmetric particles are messing with the muon's wobble, it could be our first clue they're real. Finding them would be like discovering a new species in the particle zoo. Another possibility? New forces. Right now, we know 4 forces: gravity, electromagnetism, and 2 nuclear forces. But what if there's a 5th, super weak force we can't see except in tiny effects like the Muon anomaly? That'd be wild. It'd change how we think particles talk to each other. Or maybe the anomaly hints at extra dimensions. String theory says the universe might have more than the 3 dimensions we see, tiny, curled up ones we can't notice. If particles are bouncing around in those, it could tweak the moon's behavior just enough to cause this anomaly. But here's the catch. It might not be new stuff at all. Scientists could have miscalculated something in the Standard Model. Or maybe known particles are sneakily affecting the muon in ways we didn't expect. They're double-checking with more experiments and supercomputers to be sure. Why should you care? This anomaly could rewrite physics. It might help us understand big mysteries, like what dark matter is, why the universe has more matter than antimatter, or even how gravity fits with quantum physics. That could lead to new tech, like quantum computers or energy sources, way down the line. It's like when electricity was discovered. No one knew it'd lead to smartphones, but it changed everything. Right now, scientists are hyped but cautious. They need more data to confirm this isn't a fluke. If it holds up though, it's like cracking open a door to a new universe. Pretty cool, right? Leave a comment below and don't forget to like and subscribe.